Today we talk about literal equations. What are literal equations? Literal equations are equations that involve several variables. When an equation involves several variables, it is called a formula or a literal equation. To solve literal equations, we apply the process of solving a specific variable. So I'll show you various examples of how to solve them, and we'll start with one-step literal equations. And this is an example. You're told d plus 9 equal m. And the question is solve for d. Solve for d. What this equation wants you to do is it wants d to be isolated to the left and every other thing here to move to the right. So remember the river? What I'll do is I'll do the inverse operation of this. This is plus 9, so I'll just do minus 9 here and minus 9 here. Remember, these are not like terms, so you cannot add them up. So what you do, you just say d. On this side, you have d by itself, d equal, and then this side you have m minus 9. So the literal equation becomes d equal m minus 9, and that is your answer. Another example, you're told one-step equations. So I'm just looking at one-step equations, and now let's look at an equation that involves division. X over P is equal to W. And you're told to solve for X. When you're told to solve for X, what they mean is, you see here X is dividing P, but the question is, how do you isolate X by itself? How to solve this? Do the inverse operation. Now this is X dividing P. The inverse of divide, let me write them here. The inverse of divide is multiply, and the inverse of add is subtract. So the inverse of divide here is multiply. So what I'll do is I'll multiply this side by P and multiply this side by P. So that X, this P and this P cancel out. So this P cancels that. So you have X equal to W and P. W times P. And this is your answer. For literal equations, you don't have to put in any values. All you need to do is ensure that the value that you've been asked for, the variable you've been asked for, is isolated by itself on one side of the equal sign, and that's it. Example 3, m equal negative h plus q. And you're told solve for q. This looks intimidating at first, but if you look at each and every one of them, I will draw the how you call that thing? I will draw the river here, and then I'll look at the opposite operation of this, so that I take this to the other side and q remains by itself. So the opposite operation is plus h plus h. So this cancels out, and then I have q on this side equal, and this side I have m plus h. And this is your answer. Does it make sense? Good. Let's try another equation. C plus D equal E. And you're told to solve for D. Solve for D. What do? Get a way of getting the C to the other side of the equation. So if this is the river right here, so this cancels by doing the negative operation. If it doesn't have a negative here, it means it's a plus here. So I'll subtract C here, and I subtract c here. So I have d equal, on this side, because this cancels out, equal to e minus c. E minus c. Do not add them together. That is your answer. D equal to E minus C. One more example of one-step equations. You have J equal to K over 7. And you're told to solve for K. Solve for K. How do you get K by itself here? So K, remember, division and multiplication, subtraction and addition. K is dividing 7. So the opposite operation is multiply 7 here and multiply 7 here. Does it look like a 7? 7. So J times 7 is 7J equal, this 7 will cancel with that 7, so you have K by itself. So K equal to 7J. Let's move on to two-step equations. Let's move on to multi-step equations. And we have 3 equal to E, and then you have 5F minus J. Then you're told to solve for E. Solve for E. How do you get E by itself here? If you look at this equation carefully, this E, it multiplies. It multiplies all this. E is multiplying all this. And multiply, divide, add, subtract. If you multiply, the inverse is divide. So it means if you divide this side by everything here and this side by everything here, you get E by itself. So this divides 5F minus J, and this side divides 5F minus J. The good thing about division is that if the numerator and the denominator are the same, then they can cancel out. So this cancels that, so that you have E equal 3 divided by 5F minus J. And that's your answer. So this is your answer right here. E equal 3 over 5F minus J. Example 2. You're told solve 3P equal to A, and then you have F plus H power 2. Solve for A. Solve for A. How do you get A by itself? Remember, A is multiplying all this, and the inverse operation of multiply is divide. So I will divide this side by F plus H power 2, and also divide this side by F plus H power 2. Don't get intimidated by the many variables. So that A, this cancels that. So you have A by itself there equal to 3P all divided by F plus H power 2. And that is your answer. This is the answer. 3P all divided by H power 2. Some people like putting the parentheses like that. Doesn't matter. In my case, the answer would be, both of them would be correct. You're told that 1 over 3A is equal to x power 2. Then you're told to solve for A. Solve for A. In this case, what I would do is You see 1 over 3 is multiplying a. 1 over 3 is multiplying a. So how do I get 1 over 3 by itself? How do I get a by itself? Sorry. This 1 over 3, what I know is if I multiply this 1 over 3 by 3 or by 3 over 1, what will happen is they'll cancel out and I'll have a by itself. So I'll multiply 3 here, and what I do to the left, I have to do to the right. So I'll multiply 3 there. So 3 times this is 1. So I just have a by itself here equal, and here 3 times that will be 3x power 2. Quite easily done. Another example. Let me take another, maybe a little bit complex. You have b all divided by 4c minus d equal to h. And you're told solve for b. Solve for b. b is dividing everything here. So how do you solve? Division, remember, is the inverse is multiplication. Addition, the inverse is subtraction. So what I'll do here is I will put this in parentheses. I will put this in parentheses like this and see what is happening here. This is dividing. So dividing, the inverse is multiply. So I'll multiply both sides of this equation. I'll multiply this side by 4c minus d. 4c minus d here. And also this side by 4c minus d. So when you multiply this and that, the reason I'm multiplying is so that I can quickly cancel out this and that. And if I cancel out this and that, I remain with b by itself. And that's what I want. b equal, now h multiplies this. You can put it like that, h and 4c minus d. There you go. That is good enough. The last one of the day, n equal a all over f minus h. And you're told to solve for a. Solve for a. Again, as I said earlier, a is dividing f minus h. So what I'll do is I will just put that in parentheses, and the opposite of division is multiplication. So I'll multiply this side by f minus h and this side by f minus h. So if you multiply this side by f minus h, you get n into f minus h, and then this side you get a. So a equal to n into f minus h, and this is your answer. So that's how you solve literal equations in 1 and 2 steps.